Hey there, welcome back to Why Math Why. It's been a little while since we put out a video there, and I figured with the oncoming school year, what better time than now? What better place than here to be going over a little bit of a crazy math problem? So I was dabbling around with an Algebra 1 class that I teach and thinking about how kids use the FOIL method. And so this might be a little confusing for those of you that haven't had Algebra 1 in maybe a while, or have never had Algebra 1, but still nonetheless, I wanted to show you how long multiplication of a problem like this right here is the same thing as doing what's called distribution using the FOIL method. In fact, you've been using the distributive property for forever. So even if you don't remember your Algebra 1, this should be pretty darn cool. So when you do long multiplication, just to review this, we multiply 7 by 2, you get 14. So carry the 1 up there. 7 times 5 is 35, plus 1 is 36. And at this point you're thinking, is he just really going to go over long multiplication? You're darn right, but in a really cool way. We carry down a 0 here. The reason being is because you're really multiplying by 10. You're not just multiplying by 1. So 1 times 2 is 2. That's really 10 times 2 being 20. And then 10 times 5, right, which would be 500. So 1 times 5 is 5, or 520. You add everything up, you get 4, 8, 8. So the answer is 884. But what I want to show you is something crazy, which is how we can rewrite this problem in a different way. I can rewrite this problem as 50 plus 2 times 10 plus 7. And you can't disagree. I mean, that is the exact same problem there. We're going to get 884, but I'm going to show you how we can use FOIL to do it and how this is the same exact thing that we've been doing. So you've been doing the distributive property for years. All of you young mathematicians since you were, I don't know, second, third, maybe fourth grade. And this is something that, well, you've only been doing since Algebra 1 or beyond. It's the distributive property, though. So how do we do it? Well, we distribute every single term from this piece to every term in that piece. So let's say that I start out with 50 times 10. Well, actually, let's go in the order in which we multiplied here. So we multiplied 7 by 2, right? So that was this part right here. So that's 7 by 2. So that's 14. So multiply that out. Then after that, we did 7 times 5. Well, that wasn't really just 7 times 5. That was really 7 times, you guessed it, 50. That part right there. So 7 times 50 is 350. Where do we get the 364 from? Well, the 7 times 2 was right here. We carried the 1, and that goes over the 10 spot, because really you have 7 times 2 is 14, and we just had the 4 down there. So the 1 gets added on, right, to that single digit right there, which makes it go up by 1 more in the 10 place, which gives you 364, which is right there. It's nuts. Okay, then we already talked about how we brought the 0 down, but really what we were doing is we were multiplying by 10. Oh, heck yeah, here's the 10. So there's 10, and we multiplied that by 2 first, so that's that multiplication. 10 times 2 is 20. Yeah, it's that number. And finally, we did 10 times 5. But really, you're doing 10 times 50, which brings the 5 down there. So 10 times 50 connects everything else. And that's plus 500. Yeah, people, that's right. That is 520. Craziness. If you're getting goosebumps right now, totally normal. 364. If you're getting a little lightheaded, not normal. Going to want to seek medical help. But hopefully some exhilaration going on here. And then we just keep adding it up, but really at that point, that's the same exact number over there on the left. So what we've shown is that you've been doing the distributive property for years. It's a different way of doing multiplication. I'm not advocating going against long multiplication. I'm just advocating for looking back at some of the operations you've done for years and seeing how it connects with some of the stuff we do later. There's a reason why we do what we do early on. There's a reason why what we do later connects with what we do early on, and how that can then proceed to show us what we can do later in math. So very cool, guys. I hope you found this enjoyable. I love it. It's just absolutely cool. I'll see you in the next video. Until then, keep mathing hard. Peace.